next lecturer. So the next lecturer is Uriel Gabay. He's a security researcher at Pentera. He has experience in red teaming and security research with a Bachelor of Science, Electronic and Engineering. He's also a security lecturer and a hacker from young age, from even birth, Uriel, as I heard?
No, from the IDF, I think.
That's a good experience. That's a vast experience.
Yeah.
Okay, so actually today Uriel will talk about his vulnerability, XSS vulnerability he found in Microsoft Azure Functions. Of course, he already reported it, so don't try to take this vulnerability and try to reuse it. It was already fixed, but he will talk about how he actually found this vulnerability, what are the ways. Uriel, so the stage is all yours. You have the control.
Thank you. If I have a delay, you just do the clicking for me, right?
I will.
Okay. So no, it's okay. Let's begin. I'll try to do the clicking. So my name is Uriel, and I'm a security researcher at Pentera. I have an experience with a lot of development of ransomware, vulnerabilities, whatever you want, any hacking related to red teaming. This is my place. So we are talking here about cloud security, right? So let's try to imagine what would happen if we find security issue in the provider itself. So we all understand that we have a direct risk to our assets, right? So in my case, several months ago, I found an XSS in Azure portal, and specifically in functions azure.com, which is one of the domains that Azure portal is using. This domain specifically is responsible for a function app service. So from this vulnerability, we can understand what's the direct impact we have on our assets, right? From an XSS, we can try to read cookies. If HTTP flag, if HTTP only flag is not set, we can read sensitive information, and we can read information from the HTML DOM. We can try to read the storage of the browser, the DB of the browser that related to the victim origin. And of course, we can send a request on behalf on the victim, and we can do a phishing campaign under the context of Azure, which is great. So I'm clicking. So the agenda for today is going to be on the next slide. Leo, can you do the clicking?
Yeah. Yes, of course.
So the agenda for today, first, I'm going to talk about the attack surface. I'm going to say a few words about Azure, about Function App. I know you're all familiar with, just a few words. After that, I'm going to talk about some security concepts. I know most of you are familiar with the terms, but just to be aligned along the session with the terms. After that, I'm going to talk about the vulnerability from the discovery phase to the exploitation phase, and eventually we're going to talk about mitigations. Even though this vulnerability is related to the provider, in my case related to Azure, still we as a client can do things that will raise a red flag in the case of attack. So the attack surface. Azure Functions is a service provided by Azure, same as AWS Lambda. You can implement your code without to be worried about the infrastructure. All the infrastructure scaling is been doing behind the scene. You just choose whatever framework you want. You want Python, you want Node.js, you want PHP, and just implement your code. Click. Okay. Azure, we all know about Azure. Azure is one of the top 3 most popular cloud service and provides 21 market share. So every vulnerability you will find in Azure you will have a great impact on people around the world, right? So click. Can you want me? But it's taking time.
Okay.
It's taking a few seconds.
No problem.
Okay. So let's talk about few browser security concepts. Again, I know you're all familiar with, but just to be in the same line. So origin. Origin is a pattern built from 3 parameters. We have protocol, domain, and port. In order for origin to be equal to another origin, we need those 3 parameters to be exactly equal. So for example, if we have http google.com port 80 and we have http google.com port 81, even though the protocol and the domain are the same because the port is different, those two are going to be counted as completely different origins. And why it's important to understand the concept of origin. Origin, it's how the browser decides to do sandboxing. For each origin, we have a different virtual environment. For example, if I'm accessing bank.com and I have cookies in front of bank.com and a bunch of data in front of bank.com in my database of the browser, and at the same time I'm opening another tab, accessing to attacker.com. So the content that's been loaded from attacker.com, the JavaScript that belongs to attacker.com cannot read the cookies of bank.com, right? Cannot, because it's a different origin, cannot read the data from the database related to bank.com. So we have some kind of virtual sandboxing for each origin in the browser. Next concept, same origin policy. Same origin policy is a policy forced by the browser, which basically is saying that one origin cannot send a unique HTTP request to another origin. What is a unique HTTP request? I will explain it in a minute, but let's give an example. Let's say I'm accessing to attacker.com and the JavaScript that's been loaded from attacker.com is trying to send the put request to bank.com. So the browser the browser sees that the content of the JavaScript is coming from attacker.com. This is one origin, and the destination origin is a different origin. It's a bank.com. So the browser is going to block the request first and then send something called pre-flight to bank.com, asking if he's willing to get a request from a different origin, attacker.com, and depends on the response that coming from bank.com, the destination origin. The browser is going to decide to release the request or drop it. So this is same origin policy. You cannot send a unique HTTP request from one domain, from one origin to another origin. What is a unique HTTP request? Unique HTTP request is when the request, for example, is with a method that is not get or post. For example, if the method is put, so the browser is gonna see this as a unique HTTP request and is gonna trigger same origin policy for them. As well, even if the request method is post, but the content type is not plain text or is not URL encoded, let's say the content type is application JSON, for example, or application XML. So even the request is with a method of post, the browser is gonna trigger same origin policy for that, meaning that it's gonna block the request and send the pre-flight. So this is about same origin policy. And just to close the circle around this same origin policy, is not relevant to the exploitation itself, but just to understand, let's say I'm a developer and I want to able to receive requests from a different origin. Let's say I have two websites, bank.com and API bank.com. Let's say bank.com is holding all my static files, JavaScript, HTML, CSS, images, etc. And I want the JavaScript from bank.com to send requests, to send a unique HTTP request to API bank.com. So I need to implement a policy, a course policy that responds to a browser pre-flight saying that I'm allowing to bank.com to send requests to me. Great. So this is about course policy. Is you cannot talk about same origin policy and not mention course policy. So that's about it. Another concept you're all familiar with, XSS, right? XSS is just the ability to run JavaScript under the context of another origin, right? So when you have the ability to run JavaScript under another origin context, you actually bypass the sandboxing protection of the browser, right? Because now you're running under a different origin. So you can access the database, read cookies maybe, read sensitive information, read from the DOM, and do whatever you want on the client side. Great. So can you click back to back, please? Oh, another one back. So we have 3 types of XSS. My type was reflected, but I'm going to say a few words about persistent DOM and reflected. Persistent XSS is when the XSS is stored in the database, and when we're accessing some pages, the malicious JavaScript that's stored in the database is pulling back from the database and running on the client side. DOM XSS is when the XSS, the malicious XSS, is triggered by a legit XSS. The legit XSS of the target server. And reflected XSS, which is our case, is when we can control on the response that coming from the server in some way. Let's see an example of reflected XSS. So in this case, if you look on the right side of the image, you'll see that we have a very simple PHP code that all it does is echoing back the input value parameter to the client, right? So by inserting into the input parameter, by inserting a content, a script content, HTML script content, we can control on the server response. And we're actually able to run any script code by inputting it inside the input parameter and running it on the client side. So this is a very basic example of reflected XSS, but the concept is when you have a control on the server response. So now let's dive into the vulnerability itself. So I found vulnerability in Azure portal and functions.azure.com, which is the domain that's responsible for Function App. So let's see from the discover phase to the exploitation phase. So this is the request, the original request I saw. So as a part of my research on Function App, I decided to intercept the traffic between my browser and Azure.com, portal Azure.com, and I saw the following request. So from here, we can sense what's going on behind the scene, what the server does with this request. We can see in the URL we have pass-through in the URL, and we can see in the body we have like parts of HTTP requests. We have like URL, headers, content type. We can build an HTTP request and sending it to functions azure.com. And I didn't know at the beginning. I didn't know what's been going on behind the scenes. So I decided to create my own website, which contain the following content. Very simple. This is an HTML code, just very small script code. And I changed the URL in the request to point to my website. And I saw that functions azure.com actually accessing my website and fetching the data back, which is great news from the attacker perspective, of course. And another note, you can see in the response that along with my fetching data, you can see that the content type is text HTML, which basically means that if the browser gets it, it's going to render it as HTML, which is great. It's going to run my script. So the answer, the question is that enough for working XSS? Because as you can see, I can control the content that reflecting back from functions azure.com. Is that enough for an XSS? And the answer is no, it's not enough. Why is not enough? We need to, if we look deep into the request, we'll see that this is a post request, right? And because this is a post request, in order to exploit it, I need to create my own website and create some kind of to create a link that when someone clicks on this link, this post request is triggered automatically, right? So if I'm creating this website and I'm sending this link to someone, I need to be worried about two things. One is to send this request exactly, because this request is the vulnerable request. And two, I need to handle the redirection. I mean, I'm sending a link to my website and I want to redirect to functions azure.com, which is a different website. So in order to handle the redirection, I need to create HTML form that doing the post for me, right? And because this is an application JSON content type of the vulnerable request, I cannot create a request based on HTML form that send in a JSON content type. It's not possible from the browser perspective. And another problem, as we all know, same origin policy. Because this is an application JSON content type and my new website is a different origin than functions azure.com, even if I could send this application JSON request, I'm going to be blocked by the browser because I'm trying to send a post request with the JSON content type from one origin to another origin, functions azure.com origin, which is a different origin. So I have here two problems, right? So there is one solution for those two problems, and it was to try to change the unique request to be not unique. Try to change the application JSON content type to application URL encoded content type. So I tried to say if the remote server will accept it. And guess what? It's, well, actually, as you can see, I changed the content type from application JSON to application URL encoded. As you can see, the body changed as well. And the server is still fetching my data. So now I have a solution for my two problems. I can create an HTML form that automatically sends this post request. And because this is a not unique HTTP request without application JSON content type, the browser is not going to block me. So let's see the exploitation. I think it's a bit scrambled, the slide. Never mind. Try to explain it. I try to explain it as is. So let's try to explain it end to end. So as an attacker, I needed to create two things. One is to create my malicious data. In my case, it was the script, the HTML, very small HTML file on the remote server. And two, I needed to create an HTML content, another link, another URL to that when someone click on it, the post request is automatically triggered and the redirection is being done, and then the server is fetching the data automatically. And that's the results. actually here you can see that I was able to create a phishing page under functionsazure.com, which is a valid domain under Azure portal. And this page looks like the login page coming from Azure. This is a very good for phishing campaigns. So that's it about the exploitation process, from the discovery phase to the exploitation. We had challenge of same origin policy, but we were able to change the request from being unique to not unique, and then to bypass the same origin policy protection of the browser. So now let's try to talk about mitigations. What can be done in order to protect ourselves? So just to be honest, this is very difficult to detect because it's not in our side as a client. We don't have access to the code, to the code of Azure, right? And so what can be done? So we can do, in general, we can do two things. One is to install some kind of add-ons, or maybe to put some network proxy to monitor all our traffic and to see if there is some kind of anomaly-based problems. I mean, if you see that some domain, in my case, let's say attacker.com, is trying to access functionsazure.com directly, so this could be a problem-based anomaly, right? And another thing we can do is to check something called reputation of domains. We can see all the domains, all the DNS requests, for example, or every IP communicate from our computer outside, and to see the reputation of those objects. If there is a problem, on those objects. I mean, there are a lot of companies collect tons of information about domains. If an attacker established a new domain and it discovered in one place, so there is like a central place that that everyone can pull a lot of a lot of information in order to understand if this object, this domain, or this IP is counted as malicious or problematic object. So I think that's it from my side.
Okay, thank you very much, Uriel. Guys, if you have any questions to Uriel, please write them down in the chat, in the Q&A. Uriel will answer all your questions. I can see that there are several questions. Let's try with something that you said. From an attacker perspective, when you are saying that you are using the JSON content type, are you also reducing the attack surface by using that?
As a developer, it prefers to use JSON content type because this same origin policy. If you think about it, we all know what is CSRF attack, for example, right? When you're doing CSRF attack, it basically means that you can send a request from one origin to another origin using the functionality of the cookies that been sent for each origin. I mean, the browser, it's automatically sending cookies for the target origin. So if you are using JSON content type, the if and CSRF attack is in place, so you cannot do CSRF attack when you have when the target request is posted with JSON content type, because this same origin policy protection by the browser. So as a developer, it's recommended to use JSON content type, XML content type from the security perspective.
Mm-hmm. Okay, understood. And can you give an example of anomaly detection for this specific attack for cross-site scripting?
So in my case, if you think about it, in my case, I was accessing from my website, doing a post request to Azure website. So I will have by the browser if a referrer header, for example, referrer header that basically saying you are coming from attacker website and the destination is Azure website. So in my case, or in every case, right, you can monitor this referrer header. What is the source and what is the destination? This is a very basic anomaly detection that we can do to protect ourselves.
Mm-hmm. Okay.
And by the way, Azure fixed it by they did two things. At the beginning, they removed the ability to communicate with the server just with JSON, right? You cannot communicate with the server with a content type that is not unique. For example, URL encoded. That's one. And after 2 months, they completely remove this endpoint completely.
Okay.
Let's see.
There is another question by David Nissim. Is asking when doing a pen test, like the POC that you explained and presented, are you using some known vulnerabilities that there are some security patches, for example, that was published over there or recently published, and try your luck since companies are not patching on a timely basis? But I think it's the method.
Okay, so this is a very good question. There are some great tools in the wild, like there is a very cool tool called Nuclei, very modular tool that it's open source, so you can just use it. But when you're dealing with big enterprises like AWS and Azure, and they have and Wix, for example, and they have their own research and red teams, and I know that they are doing this kind of, they are running their tools against their endpoints. So if I need to split the vulnerability into two categories, there is one category which is, you just said, it's just scanning for vulnerabilities, and number two is to find things in the logic, to find vulnerability in the misconfiguration and in the logic of the application. For example, authorization bypass or authentication bypass, which is, there is no tool that checking it for you. So the second part is more common to find in big enterprises, but when you're talking about small enterprises, it's very recommended to run a vulnerability scanner whatsoever.
Of course. Do you want to elaborate related to the blog?
Yes, you all invited to visit our blog, Pentera.io, in Pentera.io /Pentera Labs, and you can feel free to contact me at Uriel Gabay at Pentera.io. So, any other?
If you have any questions to Uriel or further understand what was the attack, you know, Uriel just explained on a high level. If you want to drill down, check the blog. Everything is over there. I think there is also more description regarding the attack. So if someone wants to get into more details, everything is there. It's and you can ask Uriel any further questions that you want. So thank you very much, Uriel. It was very insightful. I think that we can learn that also our cloud providers might have security vulnerabilities, and eventually that might affect us. So first of all, choose a secure cloud provider. Let's start with that. And even following that, build your defense layer. So one defense layer might be your cloud provider. The second should be something that you need to protect yourself, like Uriel said, anomaly detection, or any other configuration, secure configuration or secure coding in order to protect yourself. I know that a WAF, a web application firewall, which is also a service that each and every, let's call it decent cloud provider has it. If not, bring your own web application firewall, the WAF, in order to protect this kind of application attack vector. So take that into consideration. Thank you very much, Uriel. Very insightful lecture.
Thank you for having me.